This video is a walkthrough of the coding challenges at the end of Activity 213 in the Computer Science Essentials curriculum in VEX Coding Studio. The first one we're going to look at is the Park It challenge. This challenge has you look at a parking lot of vehicles with spaces and lanes and occupied and unoccupied spaces, and create an array that will reproduce that in VEX Coding Studio, and then code that will go through and look for the empty spaces within the parking lot. So you can see the first picture here shows what the parking lot might look like, and then shows a layover of a grid that can be used as the guide for the array. So the first step is going to be creating an array that's going to indicate whether it's a driving space, like these blue squares are indicated, it's an open parking space like these green squares indicate, or a red parking space, which is a occupied space. And it says to put 0 for the aisles or roads, 1 for red or filled spaces, and 2 for available spaces. And then the goal of the program is to iterate across the array and check for the open spaces and come up with a count for how many spaces are open in the parking lot. So here is a new project in VEX Coding Studio that we'll use to start building this project. Always a good idea to start by naming the project. We'll call it 213 Park It, and then saving it right away. Make sure that when you save it, you do not change the name that you entered on the VEX Coding Studio screen. So we'll save it here in, I'll make a folder here called 213. Now the first task is going to be to create an array that we can use as our map for the parking lot. So over on the side of the VEX Coding Studio, you can do an array, add an array. We'll call it parking lot. It'll be a 2D array. And we want it to have 5 rows and 5 columns. As you can see down here, it creates a blank array filled with zeros, and we'll go back and enter in the values of the parking lot. So remember, we want to have zeros for the driving roads, and 1s for the filled spots, and 2s for the available spots. The first row, which is these 5, was a driving row, so we'll leave that as zeros. The second row started with an aisle spot, then there was an empty spot, so that's a 2 filled spots, and then another empty spot. The next one had a 0 at the start, then 2 filled spots, so make those 1s, an empty spot, and a filled spot. The next one was all driving spaces, and the last one again started with a driving space, then a filled spot, 2 empty spots, and a filled spot. Now the array is set to go. We can bring out a block for a when started. Now what we're going to be doing is iterating across this array, and we're going to be checking to see if the value of the spots is equal to what we're looking for. And specifically, we're looking for spots that are marked with a 2, so we can figure out how many open spots there are. We're going to need a variable to store how many open spots there are, so we're going to add a variable. So we'll just add a number here, and we'll call it open spots, when that starts out as 0. Then every time we find an open spot, we'll add to that number so we can get a total when we're done. So we're going to need to do a while loop, and we're going to go across each value for each row, and then also across each row. So we're going to be looping across the 5 elements in each row, and then across all 5 rows. So that's actually going to be a nested while loop, a while loop within another while loop. Let's start by bringing a while loop out onto the screen. Now, it starts out being here and says while true, because a while loop has to check a conditional to see if it's true, and it'll continue doing the thing while it's true. We don't want it to do it forever, which is what this would do right now. We only want to do it as many times as we have rows in our array. So we want to have a counter that we can keep track of how many times we're going through. So for that, we're going to add another variable. So we'll add a number variable here. And a common way to iterate across rows and columns in an array is to use single letters as your iterator. So we're going to do that. We're going to use I as our first iterator. And we're going to add in here a conditional that says we want to keep going as long as I is less than 5, which is how many rows we're going to do. So I'm going to jump over to text here. It's a little bit easier to edit it there, while I is less than 5. And the way that's going to work is we're going to have the first time through, I is going to equal 0. The second time through, we'll add 1 to it, and I will equal 1. Third time through, I will equal 2. Fourth time through, I will equal 3. Fifth time through, I will equal 4. So we only want to go through it 5 times. If after the fifth time through, I becomes 5, when it comes back to this and says while I is less than 5, it's going to say no, that's not true because I is now 5. So it's going to drop out of this while loop. So even though we start at 0, we put that 5 there because we want to continue while it's less than 5, not when it's equal to 5. Now I'm going to jump back to blocks because now we need that second while loop because we want to do something for each row. And the thing we want to do for each row is check and see if each space is open. So once we get to the first row, we have to now go through and check the first space, second space, third space, and fourth space. So we need another while loop to go through and check each one. So I'll bring in a second while loop. And I'm going to do a similar thing. I need a number to iterate across. Now, I don't want to use I because that's keeping track of the number of rows I have. So I'm going to use another number. So I'll do a new number. This one I'll just call J. And this is going to keep track of which column I'm in or which space in the row I'm in. I'll do the same type of thing. I'll bring in a while less than. But I'll change that back to while I is less than, or excuse me, while J is less than 5. Alright, now we can start doing something. We're going to be going through every item here for each row and each item in each row. And the thing we want to do is check to see if the value is equal to the empty spot that we're looking for. And again, the open spots were marked as 2's in the arrays. So we want to check and find out if that spot is equal to 2. So we'll do that with an if statement. And we want to find out if the spot we're on is equal to 2. So we're going to bring out this is equal block. We'll jump to text. Now, the thing we're checking for is if the spot of the array is equal to 2. So I'll put a 2 here. Now, the thing we have to do is figure out how do we identify which spot we're looking at. Well, we're going through our array, and our array is called parking lot. So we're going through we want to find out if the spot we're on in the parking lot is equal to the number 2. Now, to identify a specific location or specific value in an array, you have to index to it. To index to a spot in an array, you list the name of the array, and then you put the first element that you're looking at, which is the individual rows. Oops, didn't want to do that. So I'm just highlighting here to show you this is this is the 0 element. This is the 1 element. This is the 2 element, and so on. And then you index to the item within that row. To check which spot you are in the row, we then have to index to the item in the row. So the first item is the 0 item, then the first 1 item, then the 2 item. So we indicate that with square brackets. So if I was checking for the first item in the first row, it would look 0, 0. But I want to go through this loop and do it for every single thing. So I can't just put a specific number. And so that's where I can use my counters that I have here, the I and the J. So I'm going to check and say, what is in the I row and what is the J item in that row. And then as this loop goes through, it's going to adjust it for whichever row and space we're on. So we're saying if the parking lot IJ is equal to 2, we want to keep track of that. So we're going to add 1 to our open spots variable that we have. So we'll simply say open spots equals open spots plus 1. So we'll add 1 to it every time. Now in VEX Coding Studio, when you put something in manually, you may not see it change color right away. Also remember the end of every line needs a semicolon. So when you get the proper syntax, it'll oftentimes pop into the right color and right spacing. Or you can jump back to blocks and then jump back to text. And if you see it format itself correctly in blocks, you're probably pretty good. Alright, so this is going to check and see if the spot we're in is equal to 2, and it's going to add 1 to open spots if it is. But then we want it to go through every single one, so we also have to iterate to the next one. So outside the if statement, we're going to add a command to increase our value here of j. So we're going to say j equals j plus 1. And that's now going to, when it's going to go through, this is the spot in the row. So you can check to see first, is it equal to 2? If it is, add 1. But whether or not it is, because it's outside the if, it's going to add 1 to it. So then j will be equal to 1, then 2, then 3, and we'll go through all of them. Similarly, we also have to iterate the I, or increment the I, excuse me. So we're going to go here and do I equals I plus 1. So now every time it goes through, it will, after it goes through all 5 spots in a single row, it will then jump and add 1 to the I, which will go then to the second row, and so on and so forth. And continue that loop through. This is what it looks like in blocks so far. So we have this nested while loop with our iterators, both I and j, going through it. One other thing we want to make sure we do is we have to reset the value of j at the end of every row. So it's going to go through and check to see, well, the first spot, check it, then the second, then the third, then the fourth, and the fifth. But after we finish that, when it comes back down here and resets the value, or adds 1 to the value of I, we also want to make sure we reset the value of j. Otherwise, it's not going to go back to the first spot in the row. This is going to go through our entire array and check to see how many open spots we have. But when we're done, we want to be able to find out what it did. So we'll go outside of our while loops here, and we will add some print for the screen. So we'll go and add a print, some descriptive text. There we go. Some descriptive text, number of open spots. We'll go to a new line, and then we will print out what we have, and we will delete the text because instead of having text we want to print out our variable. So we'll print out open spots. Alright, and notice that the context color changes. I had to jump to text back to block. Sometimes you need to do that, but now we can see it's white indicating it's pulling it from the variable. Alright, we'll now be ready to test this and see if it works. Alright, to test it now we have to download it to the SDV. So I have, you can see my USB plugged into my brain, and we will download it here. So from VexIQ we choose the slot, or Vex Coding Studio we choose a slot and we download it. It says downloading and success. If we look at the programs, we can see that Parquet is there. So now when we run it, it should display the number of open spots. It found 5. Now just to check to see if it was working, we can go back over here in the program and adjust our array. Let's say that 2 cars have left, so these 1s have now become 2s. Now I'm going to change this to 2 and save it again, and then download it again. Now you can see it says Parquet 2. When I run it, shows 7 open spots, which is correct because we have 1, 2, 3, 4, 5, 6, 7 total 2s there. And that's the end of this part of the activity. The next activity in 213 is the Doing Donuts activity, and the task is to have the self-driving vehicle navigate a spiral path starting from the center, moving out in a incremental path to the far corner. The instructions talk about using 2D data array, using nested loops and a 2D array, but the answer code and the skeleton code provided don't actually use a 2D array. So I would suggest sort of ignoring that part of it and saying that that's not really how it's being implemented. There'd be a way to implement it with a 2D array, but I don't think that's the most efficient way to do this specific program. I'm going to start by explaining the code that is provided in skeleton format and the example code as the answer on how they did it, and then also give an alternative way to solve this task. So first of all, to sort of understand the layout and look for some patterns in the layout here, and it'll help identify how they went about it in the example code. So the self-driving vehicle starts in the center square, and he's doing only right turns, and it is doing a consistent pattern of going forward 1, turn right, forward 1, turn right, forward 2, turn right, forward 2, turn right, forward 3, turn right, forward 3, turn right, forward 4, turn right, forward 4, turn right, and then they can finish off with a forward 4 or forward 5. The example code actually goes forward 5, turns right, and goes 5 more, so it adds 1 more leg on this spiral. And then the way that they have broken that down then is they've considered each of those incremental amounts of the same amount forward in a turn as a stage. So stage 1 is go forward, turn right, go forward, turn right. And then the second stage is forward 2, turn right, forward 2, turn right, and 3, 3, 4, 4, 5, 5. And now looking down here at the code, the skeleton code that they provided, so they're using stage to be those 5 increments of forward right, forward 1 right, forward 1 right, forward 2 right, forward 2 right, 3 right, 3 right, 4 right, 4 right, 5 right, 5 right. And then the count to be 1 time through, 2 times through for each stage. And then the step to be how many steps they take. And that's going to be the stage number plus 1. The reason it's going to be plus 1 is because the stages are going to be labeled as 0, 1, 2, 3, 4. So in stage 0, which is going forward 1, it's go forward 0 plus 1, 1, 1. Stage 1, which is the second stage, will be going forward 2. So it'll be 1 plus 1 is 2, 1, 2, 1, 2, so on and so forth. Then as they go through, they're simply broadcasting and waiting straight every time. They're going to increment the step so that they are going through enough times, and the count to go through each time, and the turn doesn't happen until after they've gone through for the number of steps that they need each time. And then there's 3 subroutines, or 3 events: the straight, the right, and the right. The straight is using just drivetrain to move forward, and then the 2 different right routines or events are for each motor. So they're doing motor spin 4 for the first motor, and then motor 2 spin 4, and it's going to be doing just a turn of the motors in opposite directions to do a right turn. There's alternatives to that as well, which we'll talk about. So now I'm going to bring in the VCS code so you can see how that was fully implemented. So it started with the events right and straight created, and then 3 variables: the stage, the count, and the step created, set at 0 initially. And now we're going to be doing it for 5 total stages, but those stages will be 0, 1, 2, 3, and 4. So it starts with a while loop. This is similar to the previous task in this activity, that will continue to do it as long as the stage is less than 5, because we want to go through 0, 1, 2, 3, and 4, and then stop when it gets to 5. The count is going to be the number of steps that each stage has, but they're using step for a different word. So it's going to go through it twice for each stage, so it's less than 2. And then the step is going to control how many steps forward it takes each time, or what step it's on in the stage, or in the count for the stage. So again, it's going to be while the step is less than the stage plus 1, because each stage is going to be, you're going to need 1 more step than what the stage number is. So it goes through, and this is at the start, it's going to be 0, count is going to be 0, and step will be 0. So it's going to come out and do the first thing, broadcast straight. So that'll drive for 10 inches straight, so it will be 1 square. And then it's going to take step and add 1 value to it. So step plus 1. Now it's going to come down and do a broadcast right. So this is going to make a right-hand turn. And then it's going to set step back to 0, and it's going to set the count to the count plus 1. So it'll have finished the first forward and turn. So step is 0, count is now 1, because it was 0, it's now 1. So now it's going to hit down here, and it's going to come back up, and it's going to check if count is less than 2, which it still is, it's at 1. It's going to do while step is less than stage plus 1. So stage is still 0, So step is 1, while step is less than 1, and step is 0, so it is. It's going to do another straight, and then it's going to add 1 to step, and that'll make step 1. I forgot to mention this the first time through the loop, but now that step is equal to 1, the while will say when step is less than 0 plus 1, which is 1, it's not going to be true, so it's going to drop out of this while loop and go back to this while loop. It's going to make another right turn because that's what it needs to do, and then it's going to set step to 0 again, and then set the count to be a count plus 1. Count was 1, so now count becomes 2. Now it drops back into the while loop and checks. Since count is now 2, it's no longer less than 2, so it drops out of this while loop and comes down here. Count is now set to 0 because it's reset every time it drops out of that loop. And then the stage is set to stage plus 1. So stage was 0, now stage becomes 1. So now it comes back up and it checks. Stage is still less than 5 because it's 1. Count has been set back to 0, so it is less than 2. Step has been set back to 0, so it's less than 2. So it adds now. It's now less than stage plus 1, which would be stage is 1 plus 1 is 2. So since it is less, it's going to go straight. It's going to set step to be plus 1. So now step, which was 0, will become 1. And since step is still less than 2, which is stage plus 1, it will go through and do another straight. So this time in stage 2, it's going to go forward for 2 squares, which is what we wanted to do. So it goes forward for 2 squares. Step now is going to become 3 because it was, or is now going to become 2 because it was 1, and it's no longer less than 2 because it was 1 plus 1. So step is 2, so it's not less than 1, so it drops out. It does a right turn, sets the step count to 0, sets the count to 1 plus 1, so now count is at 1, and it goes back and it does the same thing again because count is less than 2. It checks if the step is less than the stage plus 1, which will be 2, which it is. So it'll go forward 2 straights because it'll go through once, set step to be equal to 1, go through twice, and then it will finish with a second right turn, drop out of this loop, make count equal to 0 and stage equal to now 2. So it's going to continue through this loop for every stage until stage is equal to 5 or no longer less than 5. So the last 2 moves it will do will be straight for 5 and then turn right, and then straight more for 5 and turn right again. So that's how this code is constructed. It's not using an array, but it is using 3 nested while loops in order to iterate through the pattern that makes up this donut. This code is available for teachers in the teacher guide, the 2.1 quick guide, so you can definitely download this and test it to see the behavior. Right, here is an alternative way that I went about solving the doing donuts task. I first looked at the path that's being laid out here, and it's always straight with a turn following it, and the only thing that really varies is the distance that it goes straight. So the route I'm going to take is I'm going to create a one-dimensional array, which is basically a list of the distances, or at least the squares going forward that it needs to go. So it's going to need to go forward 1 square, then 1 square, then 2, then 2, then 3, then 3, then 4, then 4, then 4. So in Vex Coding Studio, what that can look like is by starting to make an array, and it's going to be called moves. It's going to be a one-dimensional array, and there are a total of 9 different drive forward segments. So I'll make it long 9, and then I'll simply put in those values. So it's going to be 1, then 1, then 2, then 2, then 3, then 3, then 4, then 4, then 4. Now I want to have 2 different events that I can call. One will be the drive straight, and another one will be the turn right. I'm going to start with when started, as typical. And I want to do the same task, basically, once for every segment it goes through. So it's going to be going forward. It's going to be going forward 9 different times for 9 different amounts, and then turning right after every time it goes forward. So I will start with a while loop. And I want to keep doing this until I am done with all of my moves. And I'm going to use, much like the previous activity, the previous exercise, I'm going to use an iterator to keep track of how many times I go through. So I'm going to create a number variable called move, and that's going to keep track of which move I'm on. So my while loop will actually be while my move. Let me go back here and grab one of these comparison blocks. While it's less than, I want it to be my move is less than 9. And again, it's 9 because even though I have 9 things, I don't want to go, it starts at 0, so it's going to be 0 through 8, and when it gets to equal to 9, it's going to be done. So when my move is less than 9, I want to do 2 things. I want to go forward, so I'm going to broadcast and wait my drive straight, and then I'm going to also turn, so I'm going to broadcast and wait my turn right. And so that I can keep track of which move I'm on, when I'm done with that, I'm going to increment my move. I'm going to do that in the text version here. I'm going to do move equals move plus 1. So now it's going to go through, it's going to drive straight a certain amount. I'll specify that in the event for straight. And it's going to turn right a certain amount, which again I'll specify in the event for turn right. And then it's going to increment move to plus 1. And it's going to go through that basically 9 times, because it starts at 0, then move becomes 1, all the way up until move becomes 9, which would be after the 9th time. But it will then stop moving because it's no longer less than 9. Now the rest of the code is going to happen in my other events. So I'm going to bring out an event, 2 different events, one for drive straight and one for turn right. The turn right is pretty basic. All I need to do is turn right, so I'm going to bring out a turn 4 degrees. And this is where there's a little bit of programming that still needs to be finished in VEX Coding Studio. It's going to be a total, 90 degrees would make sense, but I think due to some just errors in the wheel size that are in there, it doesn't exactly work out to that. So in my testing, I found that 83 degrees is a good 90 degree turn, but you'll just have to test that or encourage your students to try that to see what works. And the amount that the wheels stick on the mat and the mat surface and all those are going to vary that accuracy. So what I found with the last time I was testing, 83 degrees was about a good right turn. Now the drive straight is going to be determined, is going to be a drive straight, but the distance it drives straight is going to be determined by my list, my array that I created. So I'm going to bring out the drivetrain drive 4, and right now it's set at 12 inches, but I don't want it to drive 12 inches. I want to base it off of my list here. I'm going to jump over to text coding to help me tweak that. Now my list is set up for the number of squares it's going to drive forward each time. And with some testing, I found that 10 inches is going to be the amount per square. But now I want to increment that to whatever the value is. So the first time through I want to drive forward 1 times 10 inches, the second time 1 times 10, the third time 2 times 10, then 2 times 10, and so on and so forth. Now I can identify which multiplier I want to use by going across my array and picking the one that I'm on. And the index that I can use for that is my variable I created, move, because the first time through move is going to be 0, and this is the 0 element in the array. The second time through it's going to be 1, and this is the 1 element in the array. Then the 2, the 3, the 4, all the way up to the 9 element in the array. So right here in the drivetrain drive 4, I can modify this and say I want to choose from the moves list the move item. The moves list is the one I created right here, moves, and the move item will be the iterator as it goes through this while loop over here. But I don't want it straight, otherwise it would just be 1 inch, 1 inch, 2 inch, 2 inch, so I want to multiply times 10 to get my total move value. So now I am going through, I'll go back to blocks here. I'll do drivetrain moves move, which is the moves list, the move item, 10 inches. Now, in testing, I also found, and I think this is something, again, that just needs to be fixed in the code, that the drive 4 number of inches actually drives the vehicle backwards, so I'm just going to add a -10 in there to be able to account for that error in the code. And some of us found this out, that when you put a -10 in, it's really easy to see here, but when you go back to the blocks, it almost looks like it disappears. But if you look really close, you can still see the negative there. So now the code is going to go through, and each time it's going to broadcast the drive straight. Drive straight is going to look up in the list how far it should go, and then do that, and then it's going to turn, and then it's going to continue that through until it's gotten through all the moves it needs to do. Let me now show you what that looks like on the mat. Here is my SDV running my alternate version of the donuts code. The last activity in 213 is the Map It, Drive It activity, and it asks the students to create 2D arrays to track where the obstacles, red squares, are on the maps, and then have the SDV navigate from the green squares to the orange squares. The way this is done in the example code, and the way I will explain it, is by simply planning a route for each individual grid and then putting in a little bit of logic using if statements to identify which grid is which when they're entered into the SDV. So one of the keys to helping the program determine which grid it will navigate will be to identify unique aspects about each grid that can be looked for by the program. So all of the grids either start either in the lower right or the upper left. So one thing that can be checked is to see where it starts. So if you can identify it starts in the lower right corner of the grid, you can then look for something unique about each one. Looking across here, grid 1 is unique in that it does not have anything in the second row, first column. So it can be checked for that. Where there is duplicate things on grids that makes them share a feature, another thing to do is identify something that is unique from that subgroup. So the rest of them here have a red square in the second row there. These 4. That's not unique. This one has a square up on top, which is not unique because it's shared here. But if we jump ahead to, well, let's see, number 4. Number 4 has the 4th row, second grid square as red. So we can check if that's true. If it is, we know it's grid 4. If it's not, we can continue looking, and we can see that This grid has a unique one in the center, also on the bottom, and we can check for that. So we can say if this one has, if it has the center square 2 2 or the bottom row fourth one set, which would be 4 4 because that's down to 1 2 0 1 2 3 4 and then 0 1 2 3. So it's 4 3. If that's red, it would be that one. And then we can go on and we can go back to these now and we can say if this one is set 0 1 2 0 0 1 2, so it's 0 2 is red, then it's this one. And then if it's not any other ones, it would be this one. And even though that's not unique from this one, if we put it in order that way, it will first check to see if it's this one, and if it's not, it will move on to check to see if it's this one. And by having those checks in a specific order, we can avoid mischoosing one because of duplicates of some of the pattern. I'll show you in the code how that was determined, encoded, and then we'll go through and code a couple of the paths so that it can go through and navigate those. To code the Map It, Drive It activity, I am starting with a new project, which I will name and save. And then I'll start by coding some events for each grid. So I'll start by naming an event grid 1. Go ahead and put a few grids in right now. Grid 2, grid 3, grid 4, grid 4, and grid 5. Now I'm going to code each of those individually. So I'll simply start with grid 1. Now the example code uses subtasks for straight, right, and left, and then assembles those into the different grid tasks. I'm just going to code each grid individually. It's about the same approach both ways. So I'm looking at the grid for the first one, and it's going to involve turning to the left, driving straight for 5 squares, turning to the right, driving straight for 5 squares. So I will start with a turn command. So drive turn for 82 degrees. As has been mentioned before, the 90 degrees isn't accurate for the turning 90 degrees, so it's approximately 82 degrees, but that's again something that you have to test and adjust as your self-driving vehicle may be slightly different. And then I'm going to go forward. Drive 4. And we want it to go forward for 4 squares because it starts on the first square. So we're going to set that at 40 inches. And then we're going to bring in a turn again. And we'll make that 82 degrees. I have to go back to this first one, because if it's going to turn to the left, we need negative degrees. Then we're going to drive 40 inches again. Oop, that's the turn 4, so get rid of that one, and the drive 4. Now, iterative development and testing is important, so now would be a good time to test this code to make sure it's working properly. In order to get it to execute, I'm going to bring out a when started block, and I'm going to have it broadcast grid 1. So I'm going to test this one before I move on. Okay, I successfully tested grid 1 working with my mat, and what I then did was I mapped out grids 2 through 5 as well, and set in the different turns and distances I wanted to drive for those grids. Then I put them all into my when started and just put a 10-second pause between each one, so I can now test it with all of the first 5 grid paths laid out and see if it works. Grid 1. Grid 2. Grid 3. Grid 4. And grid 5. Alright, so the next thing is to build the array to indicate what grid is active, and print that out on the screen, and then use some conditionals to check which grid is active so that we can run the right code. So I'm going to start by creating an array here. We'll call it my array, and we will make it a 2D array that's 5 by 5. And for the sake of testing, we'll set the first array to be equal to the first grid. 1 will equal the goal, 2 will equal an obstacle, and 3 will equal the starting location. So in the first grid, the first spot is the goal, the last spot is the starting location, and the third spot on the first row is an obstacle. Now, using some code similar to what was already put in the previous activities here, I'm going to first of all get rid of all these because we don't need any of those. We're going to display that on the screen. So I'm going to need a couple of iterators, and these are just going to be numbers. So I'll add an I and a J. This is going to work much the same way as some of the other ones did in this activity. So we'll start with a while loop. And we'll say while I is less than 5. And then we will throw in a second while loop. And this one will be while j is less than 5. And we simply want to print the individual values. So we can use a Brain LCD print. But instead of printing text, we are going to be printing values from the array. So we'll be printing my array I, which will be the row, and j, which will be the item in the row. After we print each item in each row, we then want to increase the value of j by 1. And after we get to the end of each row, we want to increase the value of I by 1 and reset the value of j. We also want to add a new line so that our array is placed on 5 consecutive lines. So that code will display the array that we have just for sake of showing it. And now we need some code to check and see which grid we're working in. So we're going to start with a conditional. And the first thing we're going to check is the starting location or the ending location. So I was discussing before, there are only 2 patterns in the grids. One of them has the starting location in the lower right and the ending location in the upper left, and the other one has the starting location in the upper left and the ending location in the lower right. So what we can check is that first square and see what the value is. So we can say if my array 0, 0 is equal to 1, which in our case it is, that's going to be the first set of 5 arrays. So that's what we're going to want for our first set. And actually I should have put an else here so for the rest of the arrays, but right now I'm just going to code the first 5 grids, and the else will be the last 4 grids. Alright, so now once we know we have, once we're fall into one of the first 5 grids, then we can start checking for which grid it is. And that's where, as I was discussing before, we can think about each grid and see how they're unique and go through a process of elimination to find the right one. I'm looking at the grids as well right now, and the first grid has nothing in the second row first item, so we can do an if statement for that. I'm going to jump over to text editing to do some copying. So if the second row 1 and then the first item 0 is equal to 0, and we already know we're in the first set of grids, we will know that we're in the first grid. So if that's the case, we can then call the function, or broadcast, call the function grid1. If that is not the case, we'll go on and we'll check something else. Actually, something else to add in here, just because we want it to stop after that, we'll just do a break after that. That'll drop out of all of the rest of this loop, or the rest of this this task, so we don't start doing a different map. So we can check the next one now. If true, and we had gone through, let me bring those grids over here again. I was talking through these before. The rest of these first 5 all have a square in that second row, a red square. And they also share some other features, like these 2 have the top middle row, these 2 have the far right row. But this one is unique in that it has the center square and also the bottom 4th square colored red. So we can check for one of those things next. Let's check for this square here. So that's going to be the 4th 0, 1, 2, 3, 4 row, 0, 1, 2, 3 item. So we will go back to text, And I'll copy and paste some code. This time, if my array 4, 3 is equal to 2, that's the code for a blocked square, then we're going to broadcast grid 5. We'll go ahead and copy this again. The next indicator, so if it's not this one and it's not this one, then, well, what else could it be? We could say if this square here is colored in, so that would be 3, 0, 1, 2, 3, 0, 1, 3, 1. So let's do that. And that'd be grid 4. 3, 1 is equal to 2, grid 4. And then we can look for this one has that square up top, the third square in the first row. Now, this one also has that square, but since we've already checked for this square with a unique identifier, if it said no, we know it's not this one. So now we can check this square because even though it's the same as this, it will have passed checking on this one. So we'll look for 0, 2 for that one. And that will do grid 3. And then the very last one of this first set of grids is going to be number 2. But we don't have to check for anything for it. We can simply say, well, if it isn't any of the other ones, it is going to be grid 2. So we can say else grid 2 for that last one. So included here in the if, I had some code break because I didn't have the right bracket, so I'm going to have to recopy some of that code. So whenever we have an if, we have to open the bracket here, close the bracket here, open the bracket here. This opens the bracket here, closes the bracket here, opens the bracket here, closes the bracket here. Not an uncommon mistake, something to watch out for. So let me go back here, and I'm going to copy this code here. Alright, so 0, 0 is the first group of grids. 1, 0, 0, we're going to do grid 1. And then we said if 4, 3 is equal to 2, we're going to do grid 5. So now I'm going to copy my if all the way down to here and put the next one in. It's easy to go back to the box to see now it's all snapping in place. Alright, so back to what we were checking. We said we would check, I said I would check 3, 0, 1, 2, 3, 0, 1, 3, 1 for grid 4. And then 0, 2 for grid 3. And then we need an else. So on this next line here, it will be else. It'll be an open bracket followed by a closed bracket. and then inside the else it's going to do grid 2. Alright, so going through the code again, first it'll check if that opening spot, the top left, is a 1, which will indicate we're in the first group of grids. Then it's going to check for some specific things. If 1, 0 is a 0, that means you're in grid 1. If 4, 3 is a 2, it means you're in grid 5. If 3, 1 is a 2, it means you're in grid 4. If 4, 3 is a 2, it means you're in grid this should be grid 5, 4. I think that's a duplicate. Let's see. 2, 3, 4, 5, 1. Yep, I think that's just extra code. So go back in here. I'm going to get rid of that one. Three, 1 is 2. It's grid 4. 0, 2 is 2. It's grid 3. Else it'll be grid 2. Now to run this program, we'll simply adjust the grid, the array for whatever grid we're on by changing the numbers, download it to the robot, and then it will check to see which array it is after it displays it, and then navigate on the path that's been pre-programmed.